Hello and welcome to A Ramble with me. We are rambling about IEB paper 2 from May 2025. Question 10. Reasons must be given in this question. In the diagram, AB and AC are tangents to the circle. Okay, so we know that AB is equal to AC using the tangents from a common point theorem. Then we're told if angle S is 120 degrees, determine the size of A. Oh, I have no idea. I'm immediately tempted to connect these two. Then I've got an isosceles triangle. Whoa. Okay, I'm just gonna go ahead and do it because I don't know. I am not really good at strategizing up front. It is a lot easier for me to just what is happening in the world? Yo, life flashing before my eyes. Okay, so like I said, we know that these are equal because of tangents from a common point. And let's say, for example, that this is x, then we know that this angle will be 60 minus x. Reason being, if this angle is 120, then these two angles must add up to 60, so that we have 180. And then who can know? Tangents, what else do tangents give us? So tangents, we're thinking equal tangents, we're thinking tan rad. We don't have a center, so tan rad is a 0. We're thinking tan-chord. We have tangents, we have chords. So for example, this angle here would be 120 because there's the chord, there's the angle in the alternate segment. Both of these would be 120. But yeah, that's not really giving us much. Is it not? So this would be 120. Let me fill this in. So this would be 120, and this would also be 120 as discussed. And so this would be we didn't need all of that fanfare, right? Because this would be tan-chord as well. So these two would be equal, and this would be equal to x. Why do I feel like I'm going nowhere slowly? Right. So effectively this angle is 60 minus x plus x, so it's 60, and this angle is 60 minus x plus x. Oh, hectic. So this is 60. Oh my goodness. Yo, okay, so we don't even need the x's at all. Here is the very simple way to solve this problem. Okay, so we solve the problem. You make me a believer. We solve the problem by constructing BC and recognizing that this is 120 because of tan-chord. So here's my chord, here's my tangent, and it is subtending in the alternate segment. And likewise, this is also 120. There's my tangent, there's my chord, subtending the 120. So both of these are 120 degrees. Right? And so this angle over here, angles on straight line, is going to be 60. Right? And likewise, this guy is also going to be 60. And so you've got 60, 60, and so that must also be 60. Just like that. How cute. Hey, so this turns out to be a nice, cute little equilateral triangle. So let's put that into words. So we start by constructing chord BC. Right, so that's that pink line that I drew over here. And then from there, we will say that, oh, how shall we say this? How do I name this angle? Okay, so this is where you gotta maximize on having a right on paper. So I'm just gonna put in my own names for the ends of these lines so that I can name these angles. So this angle would be angle XBC is equal to 120, and that's because of tan-chord. And similarly, angle YCB is equal to 120 because of tan-chord. Right? And then from there we would say this angle, angle ABC is equal to 60, and that's because of angles on straight line. Right? And you know, we don't even need this guy, because you could have said that this is 60 just because of equal tangents. So yeah, this being 120 would give us, well, no, this being 120 gives us this being 60, which can give us this being 60 without us needing this. But anyway, many ways to arrive in Rome. So angle ACB is also equal to 60 because of angles on a straight line. And then finally, therefore, angle A would be equal to 60 degrees because angles in a triangle add up to 180. Wow. Okay, so that started out menacing, but once the construction was in place, everything else kind of came together. Let's have a look at what the memo thinks. Oh, so they do indeed start by joining BC, and then they say SBC is equal to ACS. SBC is equal to, oh guys, I think I'm gonna need another diagram. Oh no. I want to select this. Okay, right. Let's go to a new page and have fun with the memo. Okay. So they say SBC, this guy, is equal to ACS, this guy. Yeah, that is true because of tan-chord. So here's my tangent, here's my chord. There it is, subtending that angle. So these two are equal by tan-chord. And then they say BCS, this guy is equal to this guy, also by tan-chord, right? There's my chord, there's my tangent, subtending that angle over there at the circumference in the alternate segment. And then they say CBS, the blue guy, plus SCB, the purple guy, is equal to 60 because angles in a triangle add up to 180. So these two must be 60, which means that these two must also be 60, right? So this and this together adds up to 120. And so the angle sum in this triangle is 180, therefore this must be 60. So that's another way that we could approach it. Wow, that is, yeah, hardcore. But yeah, like I said, so many ways to arrive in Rome. And as long as your map, your GPS is up to date, your directions are, you know, making sense, then no matter what route you took, it should be fine. Anyway, enough rambling. Big yawn. Yeah, okay, I think I'm gonna call it a night. Thank you for joining the ramble, and see you another time.